In this lesson, we will practice graphing 8 important functions. By using 2 or 3 key points, each of these graphs can be quickly sketched. Our first graph is the identity function y equals x. The 3 key points include x values of -1, 0, and 1, resulting in y values of -1, 0, and 1, where y equals x, and the corresponding ordered pairs of -1, -1, 0, 0, and 1, 1. Let's plot these 3 points on our graph. Remember that y equals x is a line, and that completes our first graph. Next, we want to graph the absolute value function y equals absolute value of x. The 3 key points include x values of -1, 0, and 1, corresponding y values of 1, 0, 1, giving us the ordered pairs -1, 1, 0, 0, and 1, 1. Let's plot these 3 points. Remember, y equals absolute value of x has a V shape, and that completes the graph of y equals absolute value of x. Next is y equals x squared. Our 3 key points include x values of -1, 0, and 1, and I've thrown on -2 and 2 here for a little more accuracy if you want to include those points on your graph. Corresponding y values will be 4, 1, 0, 1, and 4, resulting in ordered pairs -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Let's plot these 5 points. Notice the extra points are in orange, the key points are in blue. Y equals x squared has a U shape and is a parabola, and that's y equals x squared. Next, y equals x cubed, the cube function. Key points include x values of -1, 0, and 1. Y equals x cubed gives us y values, including -2 and 2 for our x values. The y values would be -8, -1, 0, 1, and 8. Ordered pairs will be -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. Again, -2, -8, and 2, 8 are included for more accuracy should you decide to include those points on your graph. Y equals x cubed. Let's draw a smooth curve connecting our points. Once you've graphed this a few times, you should easily be able to remember what the graph looks like and sketch a quick graph of y equals x cubed. Y equals square root of x. For this function, the square root function, the domain is limited to x values greater than or equal to 0. So in this case, our 2 key points are going to include x values of 0 and 1, with x equals 4 giving us an additional point for accuracy should we decide to include that. The corresponding y values will be 0, 1, and 2, resulting in ordered pairs of 0, 0, 1, 1, and 4, 2. Let's sketch these 3 points and connect with a smooth curve. This is y equals square root of x. The cube root of x, the cube root function, we will use the key points here with x values of -1, 0, and 1. -8 and 8 are included for further accuracy. This results in y values using y equals cube root of x of -2, -1, 0, 1, 2. We have the ordered pairs -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. We'll plot these 5 points, connect with a smooth curve, and this is the graph of y equals cube root of x. The reciprocal function, y equals 1 over x. Here, x cannot be equal to 0. Remember the domain. And so let's use, this time I'll actually only include 2 x values in my key points, -1 and 1, but we'll be plotting 6 points here for a little more accuracy. And the corresponding y values to negative 2 would be negative 1/2. We'll have negative 1, negative 1, negative 1/2, negative 2, 1/2, 2, 1, 1, and 2, 1/2 as our ordered pairs. Plotting these 6 points, connecting with the two smooth curves in this case, will give us the graph of y equals 1 over x. Next, we'll graph the reciprocal square function y equals 1 over x squared using these same 6 x values, with negative 1 and 1 being the x values included in our key points. We'll have the ordered pairs of negative 2, 1/4, negative 1, 1, negative 1/2, 4, 1/2, 4, 1, 1, 2, 1/4. We'll plot these 6 points, connect with two smooth curves, and this is the graph of y equals 1 over x squared. Try on your own graphing y equals 1 over x.